So we had started talking about carbonates. I told you about carbonates that they react with acids to produce salt, water, and carbon dioxide, and we did a lot of reactions of those, and we tried balancing equations as well. Uh, so sodium carbonate with nitric acid, and so on. So all carbonates they react with acids to form salt, water, and carbon dioxide. So these were some reactions which I had asked you to write, which you did send me. For example, calcium carbonate with for example, calcium carbonate with phosphoric acid. So that is calcium 2 plus, CO3 is minus 2. So the reaction would be with phosphoric acid. What is going to be the salt that would be produced? That get rid of the H and replace it with calcium, and that would result in the formation of CaPO4. Ca is 2 plus, group 2. PO4 is 3 minus, so that the formula would be Ca3, and PO4 would be twice. Plus there's going to be water, and there is going to be carbon dioxide. So that is the reaction that will happen when a carbonate reacts with an acid to form salt, water, and carbon dioxide. And we can rub off the charges. We need to balance this equation, and if you balance this equation, it's going to be, you start off with the easiest. You start off with calcium, the one that appears in the least number of places. So there are 3 calciums over here. So over here, there's going to be 3 calciums as well. And then you'll balance something that's easy to balance, carbon. That's 3 of them. I mean, there's 1 carbon, but there are 3 molecules, so 3 carbons. Over here, there's 1 carbon, so you'll multiply this by 3 as well. What is easy now? H, that's 3, that's 2, so you multiply this by 2. And you multiply that by 3, so that you can have 6 hydrogens, right? And there are 2 P's over here, and there are 2 P's over here as well, so that's already balanced. So oxygen would automatically get balanced. The one that was the most difficult to balance. It was everywhere, in every place, so kind of difficult. So that would balance on its own. So I'm just going to revise all the reactions that we have done so far. Number 1, you're starting. Just let me draw the margin just a second. So starting with the first one, which was that we did the first one, which was just a second. Starting with the first one. The first one was that we did metal plus acid. Just a quick recap of all the reactions. So metal plus acid. And that would produce salt plus H2. So we did a lot of reactions for that. We did magnesium with some acid, let's say nitric acid, which is HNO3. How do you form a salt? Get rid of the H. The Mg is going to take its place. It's going to be Mg and NO3. Now Mg is 2 plus, NO3 is 1 minus, so the formula would be Mg NO3 twice, plus there's going to be H2 gas. Second one, we did base plus acid. And that would form salt plus, that is going to form salt plus H2O. So what's a base? Base was, I told you, it was oxides and hydroxides. So for example, any oxide, hydroxide, that's a base. So one example was, I mean, this was our second reaction, just a second, that we did. So base plus acid produces salt plus water. So for example, you have calcium oxide, with any random acid, let's say HCl. The H would be gone, calcium would take its place, Ca and Cl. Ca is 2 plus, Cl is 1 minus, so it's in group 7, so the formula would be CaCl2 plus there's going to be H2O that's going to be produced. That was a base plus acid reaction. And oxides and hydroxides, so it could be a hydroxide as well, like aluminium and hydroxide. So that's OH is 1 minus, Al is 3 plus, so the formula would be Al and OH would become 3 plus, there's going to be H2SO4. So replace the H with aluminium. 3 plus, SO4, 2 minus, it's going to be Al2 and SO4 plus H2O. Okay, is this clear so far?
Yes, sir.
Yes, sir.
And then we did a third reaction as well, and that third reaction was a carbonate reacting with an acid. So उसके अंदर there would be salt, water, and there's going to be a carbon dioxide molecule that's going to be produced as well. So in that case, the reaction was, in that case, the reaction was that you had, let's say, sodium carbonate, Na is +1, CO3 is -2, so it's going to be Na2CO3 plus any let's say H2SO4. So the salt would be, instead of the H, there's going to be Na. Na is +1, SO4 is -2, so it's going to be Na2SO4, plus there's going to be water and there's going to be carbon dioxide that's going to be produced. So we did these three types of reactions that you can see on your screen. That's, let me underline the first one as well. So that's a first reaction. So we did these three reactions. Okay, you must remember the name of the acids, you must know the ions. Okay, there's a list of ions that should be remembered, their charges, their formulas, everything should be remembered. Okay, is this clear up to this point? Okay, Zainab, Saneem?
Yes, sir.
Yes, sir.
So now what we're going to do is we're going to learn about solubility. We need to write the states. As an example, I'll just write the states. I mean, this is solid, this is aqueous, and this is aqueous, and H2 is a gas. Now, what does aqueous mean? Aqueous means that it's dissolved in water. So, like if you have table salt, NaCl, that's dissolved in water, that's aqueous state. Remember, on planet Earth, most reactions, they happen in water. Like all the reactions that are happening in the human body, I mean, we are, I think, 70% water. All the reactions that are happening in blood, in your cells, they're all happening in solutions. Most of the reactions on planet Earth, they happen in solutions. Plants are, I mean, that's why we all need water, because all the reactions are taking place in water, are taking place in aqueous state. Not all, but most of them. I mean, there are obviously reactions that are happening in air as well, but 70% of the Earth's crust is water. Even the soil, it contains water. That's what plants survive on. That's why we all are constantly drinking water. All living forms are constantly trying to consume water, because if you run out of water, the solutions in your cells, in your blood, etc., it's going to dry up. So aqueous state. So that is what aqueous state is. So the thing we're going to discuss now is, we're going to come back to the equations in a bit, but the thing that we're going to discuss now is the solubility of these substances. How did I know which substance dissolves and which doesn't dissolve? So we're going to talk about solubility, and I'm going to discuss the solubility of all compounds. But let's start with ionic compounds, because most of these compounds are ionic. Like, I mean, it's a bunch of ions sticking together, right? It's a positive ion attached to a negative ion. So these are ionic compounds. So what do we mean when something dissolves in water? So here's your typical giant ionic lattice, which we did do earlier. So this one, let's copy this image. So here's a typical giant ionic lattice. What it is it's a bunch of positive and negative ions all kind of sticking together, right? And alternatingly, a positive ion is attracted to a negative ion is attracted to a positive, and so on. So that's your normal table salt, that's your NaCl. What exactly happens when you try to dissolve NaCl? So let's have a beaker, and I have this beaker and I'm trying to dissolve NaCl in water. So here's my water. The first thing is when I take a crystal of NaCl, I'm going to put it in water and I'm going to stir it vigorously. When I stir it, I'm going to use a spoon and I'm going to vigorously shake it with water. I'm going to try and stir it vigorously with water. What happens is that there's a force of attraction that's keeping them all together, but my vigorous stirring with a spoon, what it would do is it would scatter all the ions. All the ions would break away because of my vigorous stirring. The positive ions and the negative ions would all dissociate. Or I can just write, instead of this, I can simply write the Na plus 1 ions and the Cl minus 1 ions, they will all kind of get scattered in water. TK, is this point clear?
Yes, sir.
So that is what happens when you try to dissolve an ionic compound. All these ions, they get scattered in water. And the reason they're not able to get together again is because you have all these tiny water molecules that are present in between. So lots and lots of water molecules, they're going to prevent the sodium ions and the Cl ions from getting back again. So this is your aqueous state. So remember, ionic compounds, and this not only applies to ionic compounds, but a lot of compounds. Ionic compounds, they dissociate or they scatter. When you stir them vigorously with a spoon in water, all these ions which were previously sticking together because they're all attracted to each other, they'll all fly off in different directions. So ionic compounds get scattered, or the word that, the technical, you're not going to use the word scattered. The word that you're going to use, or the scientific term, is they dissociate. Not get dissociate, they just dissociate. Okay, so ionic compounds, they dissociate in water. And all the positive and negative ions, they all fly off in different directions. And when that happens, so this is what's going to happen. Like NaCl aqueous, in reality, the ions are no longer together. In reality, the ions have all scattered away. They've broken apart. So the sodium ions are separate from the Cl ions now. So this is how you write ions in a compound in dissociated form. Acha, is this point clear? We did do this earlier.
Ji, sir.
ठीक है, is this clear to everyone? Salim, is this clear? To Rahan? Okay, Amna, is this clear? Yes or no? You can. Zainab,
Yes, sir.
Acha. Anyways, your ionic compounds are dissociating. And they're breaking away into positive and negative ions. Now, the thing is, and one very important point is, why do they, not all ionic compounds are soluble. Some are soluble and some are not soluble. So if the force of attraction is weak, so you can say if they have weak ionic bonds, like if there's very little force of attraction, the positive and the negative ions, the attraction is weak, then the ions would get scattered very easily and they will mix with water very easily. So weak ionic bonds or ionic lattice, they dissolve easily. I mean, it's just, I mean, you can even lightly stir your spoon and the ions will all get scattered. Okay? Afan, is this clear? कहाँ पे हो साहिर ज़ैनब? Can you hear me? ठीक है.
सॉरी सर, असल में साहब मेरा एयरफोन सही से काम नहीं कर रहा, पता नहीं क्यों अटकता है, तो मैं बोलने के
ठीक
चक्कर
है.
में होता हूँ माइक।
चलो ठीक है. अच्छा, anyway, so इस पे हम just hold on 1 second. Forget this. So, ठीक है. So the point is that weak ionic bonds, if the ionic lattice is really weak, it can dissolve easily. The ions can get scattered easily. But on the other hand, if you have a very strong ionic lattice, so something that has very strong ionic bonds. I mean, the table salt that you have at your home,
वीक आयनिक बॉन्ड्स होगा ना?
it has weak ion. I mean, you can even break it with your hands. Okay, you can crush it. Okay, so the lattice is not that strong. So when you vigorously stir with a spoon, the ions all scatter. But if something has a very strong ionic lattice, okay, if something has very strong ionic lattice, it's not going to dissolve easily. It's not. I mean, the ions. It would be very hard for you to actually. But you would have to really uh, stir the crystal very strongly because the ions will not scatter because they would be attracted to each other so strongly. An example is marble. Okay, marble is an ionic compound, but yeah, I mean, okay, if you put a piece of marble in water and even if you try it with a spoon, stir it with a spoon, it's not going to dissolve. Uh,
यस सर।
Concrete is also, I mean, concrete or I mean, your house is made from, it's basically an ionic compound. The walls of your house are ionic compounds. So you try to take a chunk of the concrete and you try to dissolve it in water, it's not going to dissolve because the ions are sticking together so strongly. So remember, the basic idea is that if the ionic lattice is weak, it dissolves very easily. Vice versa, if the ionic lattice is strong, then it would be very hard for it to dissolve and it's not going to be very soluble. और इसमें ये कि how do you figure out which one has a strong lattice, which one has a weak lattice? ठीक है, we did do this, the strength of lattices. So what determines the strength of these
फोर्स
lattices?
ऑफ अट्रैक्शन।
I mean, that's the force of attraction. So if you have greater charge on iron, right?
सर सो फिर ग्रेटर फोर्स ऑफ अट्रैक्शन होगी।
Okay, so for example, NaCl is a weak lattice. Why? Because it has sodium ions and it has Cl ions. But the +1 and -1, they don't have a lot of attraction, right? But something like MgO, where the charge is +2 and -2. Salim, not the ratio of the ions, because in reality you have a lot of ions, okay? I mean, there are billions of ions, okay? It's not the ratio of the charge. I mean, the charge determines the ratio. So in that way, you can say that, but basically it's the charge. I mean, if you have something that has a +2 charge and another thing that has a -2 charge, then these two ions are going to attract each other very strongly.
जी सर।
Similarly, even if the charge, like aluminium oxide, aluminium is +3, O is -2. So the force of attraction between these two ions is going to be even stronger. So these compounds would probably not be soluble. This one, the ions will get scattered. You can break the ionic bonds very easily. Just slightly stir with the spoon and the ionic bonds, all the ions would fly off. Okay, so this would probably be very soluble. So that's the basic idea of solubility. Okay, if you have greater charge on ion, and there's another factor which actually determines that, smaller ions also form strong, like smaller ions, they're more tightly packed, so and they're closer to each other, so they also form strong bonds. Vice versa, and the other one is if it has a greater charge, then it's going to form strong bonds. So anyway, so this is like the positive and negative ions all attracting each other. So that's so we got the basic idea of what solubility is. What happens when ionic compounds dissolve?
ठीक है सर.
So I'm going to write the main point which we just discussed. The main point is lesser charge. That kind of indicates more soluble. And if the ion has so if the ion is greater charge, then that means it's going to be less soluble. Is this point clear?
ठीक है सर. जी सर.
Yes, sir.
But the thing is, I mean, that's the first basic thing. So whenever you something, whenever you see something that has lesser charge, I mean, you'll probably you can guess that it's soluble. Like NaCl is soluble. KCl would also be soluble because +1 and -1, so you can kind of guess that that's soluble.
Okay sir.
But if something has really like a lot of charge, for example, you have calcium phosphate +2 and phosphate is -3. Okay, so that kind of indicates that calcium phosphate would probably not be soluble. Okay, the force of attraction between the ions is too strong. Okay, your stirring with a spoon would not actually scatter the ions. Okay, is this point clear?
Yes, sir.
सर पॉलीटॉमिक आयंस जो होंगे वो सोलुबल होंगे या इनसोलुबल?
नहीं वो तो I mean, think of the polyatomic ion as an ion. ठीक है, it's just an ion. क्या charge है इसका? -3 है ना?
यस सर.
So -3 ion would attract the +2 ion very, very strongly. There's going to be a lot of force of attraction.
अच्छा, ओके सर.
ठीक है. But a polyatomic ion is just any other ion. अच्छा, now the thing is कि इससे आगे क्या करना है कि इसको थोड़ा अच्छा now the next thing is कि we've got we have to learn the solubility table. Like we got the general idea of what solubility is. What we're going to now learn is the general idea of what exactly what solubility is. As first thing is anything that's group 1. I told you that lesser charge means it's more soluble. So group 1 has I mean that's the first point. So group 1 has +1 charge, NH4 has +1 charge, NO3 has -1 charge, and anything that has H+1 in it, they're all soluble. Anything that has H+1 in it kind of indicates that all acids are soluble. So whenever you see a compound that has group 1, NH4+1 or NO3-1 or any one of them in the formula, they will be considered to be soluble. Examples are NaNO3, that's soluble. It's going to mix in water, it would form an aqueous solution. Another example is HNO3, that is soluble because H+1, NO3-1, they would dissociate. ammonium sulfate. So SO4 is -2, so it's going to be NH4 twice and SO4. So that is also going to be considered to be soluble. Why?
Okay,
Because
sir.
you've got NH4 plus 1 in it. So whenever you see any formula that has any of these ions, that compound would probably be soluble. Okay, is this point clear?
Yes, sir.
ठीक है, बाकियों भी clear है? Just type yes or no in the chat. So now the other thing is let's move to the second point. The second point is let's talk about sulfates now.
सर NH4 प्लस एंड NO3 ये एग्जांपल है?
नहीं, ये सारे ions ना,
अच्छा, ओके सर.
whenever you see any compound जिसके अंदर if it has any of these ions, then that means कि force of attraction क्या होगी, that's going to be weak and they would scatter easily in water.
ओके सर.
So they would dissolve. अच्छा, what if a compound has SO4 minus 2? So they are also mostly soluble, are all soluble, but with plenty of exceptions. So except the following. The following are except BaSO4. Okay, that is not soluble. SrSO4, that is not soluble. PbSO4, not soluble. Ag2SO4, not soluble. And you've got calcium sulfate as well. This one is partially, it is partially soluble. Okay. So these are the ones that are not soluble, so it's going to be harder to remember this, but sulfates are soluble, most of them, except for these 4-5, they are not soluble. Otherwise, all of them, like sodium sulfate, iron sulfate, any other sulfate, copper sulfate, they're going to be mostly soluble.
ओके सर.
So let's talk about carbonates and phosphates. So any compound that contains these two ions, because charges are now increasing, so they are most likely not soluble. So they are mostly not soluble, but with plenty of exceptions. The exceptions are the ones that we have discussed earlier, except the ones with group 1 or NH4 plus 1. I mean this one. Like if the compound contains group 1, then it's going to be soluble. Like Na2CO3 or Na3PO4. They would be soluble, but otherwise they're mostly not soluble. Okay, is this clear?
Yes, sir.
अब इसकी practice करते हैं, ठीक है? And then you have the fourth point is about halides, Cl. Halogens are group 7, ठीक है? They're called halogens. When I say halide, IDE आ जाता है, so that means I'm talking about the negative ion. So the negative ion of halogens is known as, we did discuss this, that when an element turns into a negative ion, तो जो end है ना, that turns into ide. So this is Cl minus 1, Br minus 1, and you've got I minus 1, right? These are mostly soluble. Except these two, Ag plus 1 and Pb2 plus. Yani if इनके साथ ना, if there is Ag plus 1 or Pb2 plus with the in the compound, then they would be insoluble. Otherwise, they are soluble. Most of them are soluble. So you have to remember this. What about oxides and hydroxides? So oxides, hydroxides. इसमें क्या होगा? इसमें ये होगा कि they are mostly insoluble. except group 1 NH4, we already discussed anything that has group 1 or NH4 plus 1 in it is going to be soluble. So except group 1 and NH4 plus 1 and some in group 2. And these include BaOH2 and SrOH2, and there's going to be one more which is CaOH2. That's partially soluble. So most of them are insoluble except for the ones that contain group 1, like if you have NaOH or Na sodium oxide, that would be soluble, or it has NH4OH, that would be soluble, and some of them in group 2. So that's your solubility table. This entire thing is your solubility table, which you have to memorize all of it, and you have to learn how to use it. So for example, I tell you what is the state of FeSO4. So these are example questions. Is it soluble or is it insoluble? So how would you find this out? You're going to look at the table. Remember, we wrote something about SO4. What did we write about SO4? Like over here, we wrote, okay, they're all soluble, except for these ones. So they're all soluble. FeSO4 is going to be soluble because it's not an exception. So it's going to be soluble. So that means FeSO4 is going to have an aqueous state. It would be in the form of a solution. Its ions would be dissociated in solution. It would be all scattered in solution. ठीक है? Is this point clear, everyone?
यस सर. सर एक क्वेश्चन. सर जिनमें लिखा होता है कि मोस्टली सॉल्युबल है, अगर हम उनका एक छोटा सा एक सैंपल उठा के अगर वाटर में स्टेयर कर रहे हैं तो इसका क्या होगा, उन पे हमें क्या मिलेगा कि वो मोस्टली सॉल्युबल, जैसे Cl-1 एंड.
हाँ, तो कलरलेस सॉल्यूशन मिलेगा ना. कलरलेस तो नहीं मिलता, बट इट वुड डिसॉल्व. जैसा
तो हम ये नहीं. यस सर.
जैसा वो नहीं होता कि if you mix NaCl in water, तो क्या होता है? You get a transparent solution.
यस सर.
But it could be colored, but it's mostly transparent. Like अगर मैं copper sulfate, ये copper sulfate था ना? This was, what example did I give? Let's talk about copper sulfate, ठीक है?
Okay.
Is copper sulfate copper 2 plus SO4 minus 2? Is it soluble or not? So sulfates are all soluble, except these are not soluble. So copper is not there. So copper sulfate is soluble and it's going to be aqueous, right?
Yes.
यो अच्छा, copper sulfate का ये होगा, ठीक है? For example, CuSO4 is a crystal. So it's something like this. 1 second. So here's a crystal of CuSO4, right? This is
Yes,
this is this thing. Okay, वो ionic lattice क्या होता है? It's this thing, right? वो जो
Yes,
blue,
sir.
ये जो blue crystal नजर नहीं आ रहा, बल्कि इसको कॉपी करके ना, let me ये कर लेते हैं, just to show you. इसको मैं इसके साथ ना I'm going to copy it, ठीक है? पता नहीं ज़्यादा देर लगी.
सर हम जिनमें जैसे Cl-1 और Br-1 में लिख रहे हैं कि मोस्टली सोलूबल हैं, तो हम इनको पूरा सोलूबल क्यों नहीं लिख रहे? क्योंकि वो तो सारे सोलूबल सारे मिल जाते हैं.
नहीं, मोस्टली सॉल्युबल का मतलब सॉल्युबल है.
अच्छा, ओके सर.
नहीं, मोस्टली सॉल्युबल का मतलब ये है कि मोस्टली सॉल्युबल जब मैं लिखता हूँ ना, तो उसका मतलब है कि एक्सेप्शंस भी है ना, एक्सेप्ट ये कि सारे सॉल्युबल नहीं है. जैसा कि मैं कहता हूँ कि नॉट सॉल्युबल, मोस्टली नॉट सॉल्युबल, ठीक है? यानी मोस्ट ऑफ देम आर,
कुछ मिल जाएगा, कुछ नहीं मिलेगा.
हाँ, एक्सेप्ट वो दी हुई एक्सेप्शन दी हुई है ना.
अच्छा, ओके सर.
इसके अंदर भी ऑल ऑफ देम आर सॉल्युबल सिवाय इन दो के.
ओके सर.
तो आई कांट राइट कि ऑल ऑफ देम आर सॉल्युबल, ठीक है?
अच्छा, ओके.
अच्छा, मैं खाली वो शो कर रहा था कि मिलेगा क्या ना, कि So that's your copper sulfate crystal you can see over here. So मतलब ये जो this arrangement, this would in reality look like this. ठीक है, that's a crystal. And copper sulfate का जो solution होगा ना, वो कर लेते हैं. Aqueous solution, ठीक है. जब वो पानी में मिक्स होगा ना तो it would look कौन सा ज्यादा अच्छा लग रहा है, एक सेकेंड. So this one. So it would dissolve to form a colorless solution. मतलब उसके सारे particles जो है ना, they'll get scattered in water. And this is how it's going to look like. अच्छा, कुछ कलर्ड होते हैं, कुछ कलर्स के ऊपर अभी हम नहीं आ रहे, ठीक है. सो आई एम नॉट डिस्कसिंग कलर्स एट द मोमेंट. बस रिमेंबर कि NaCl है ना, जिस तरह इट्स नॉट कलर्ड, ठीक है. तो उसका सोल्यूशन, बट दे फॉर्म अ ट्रांसपेरेंट सोल्यूशन. आई मीन
Okay, sir.
you can't see the particles. मतलब कोई भी solid particle आपको इसमें नहीं नजर आ रहा, because all the iron has completely mixed with water. All the ions have completely scattered. Is this clear?
ठीक है सर. यस सर.
अच्छा, अब ये कि so you've got FeSO4 and CuSO4. Uh, these are the ones that are aqueous, ठीक है.
सर यस.
well, किसी और का एग्जांपल कर लेते हैं. Let's keep doing examples. Let's say we have calcium carbonate, right? Now, what is calcium carbonate? How do you figure out? Remember, we wrote something about carbonates, ठीक है. So go above and look at carbonates. Carbonates के बारे में क्या लिखा हुआ है? They're mostly not
नॉट
soluble.
सोल्यूबल.
तो इसका मतलब है calcium carbonate except for group 1. Now, calcium is not group 1.
यस.
तो इसका मतलब है it's not an exception. So calcium, तो हम पहली वाली लाइन ही पढ़ेंगे. Calcium carbonate is not soluble. तो if it's not soluble, then it's going to be a solid. अच्छा, एक और कर लेते हैं. Let's say copper chloride. तो Cl-1, we wrote something about Cl-1 के Cl-1 के जो compounds हैं, they're mostly soluble, right? इन दो के अलावा they're mostly soluble. तो copper chloride would be soluble, so it's going to be written as aqueous. पानी के तो mix हो जाएगा. Let's do Fe3PO4 twice, iron phosphate. ये क्या होगा? Soluble होगा, aqueous होगा या not soluble? PO4 के बारे में क्या लिखा हुआ है कि most of them are not soluble.
यस सर.
Exceptions group 1 है, ठीक है, but this is not group 1. Fe is not group.
ट्रांजिशन मेटल है.
So वो ऊपर वाले ही पढ़ोगे. It's not an exception. They're mostly not soluble, ठीक है. So this one is not soluble and it's going to be a solid. It's not going to mix in water, ठीक है. जैसा marble का piece है ना, it doesn't dissolve in water. The same would happen over here as well.
सर नॉन मेटल की एग्जांपल.
नहीं, नॉन मेटल तो हम कर ही नहीं, we're dealing with ionic compounds.
ओके. ओके यस सर.
ठीक है, ionic compounds में एक positive ion है and there's a negative ion, right? मतलब
ओके सर.
अच्छा, what about PbBr2? PB2 plus Br-1. ये क्या होगा? जल्दी से बताओ. सामने लिखा हुआ है. Is it a solid or is it aqueous? मतलब will it dissolve? Will it not dissolve?
सर
It'll
it
dissolve,
will
so it's
not.
aqueous.
No.
Amna, it will dissolve or not? It will?
Sir, I think it will. Oh no, it won't. It won't. Sorry,
Ah.
sorry.
Okay, for Br-1, you've got, they're mostly soluble, except this one, Pb2 plus. Like if it's with Pb2 plus, it's not soluble. So this one will not dissolve. It's an exception. Like most of them will dissolve except for these two. ये दोनों, if they are with this thing, then they would not dissolve. ठीक है. तो try and remember this solubility table. ठीक है. That's another task. Make sure you write such things at the end of your notebook so that you can always refer to them. So these are some things that you have to memorize. So I'm posting it in the group.
ठीक है सर।
चल ठीक है, लेट्स कंटिन्यू टुमारो देन, ठीक है? ओके, टेक केयर।
ठीक है सर, हाफिज।
हाफिज।
Allah Hafiz, sir.
Allah Hafiz, sir.
हाफिज।